Morning, everyone. Thank you for joining us today for our webinar hosted by Technical Account Manager Peter Souter. Today, we will be discussing how to use HashiCorp Vault with Hiera 5 for secret management with Puppet. I'd like to introduce you to our presenter today. Peter Souter is the Technical Account Manager at HashiCorp. We also have Andrew Brader here, Principal Solutions Architect at Puppet, who has been a longtime partner. Peter and Andrew will walk you through a demo of how to configure and use Vault with Puppet as a secrets management tool. I also want to note that this webinar is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. And with that, let's go ahead and get started. Peter, you want to take it away?
Thanks, Amanda. Let me just get my screen share working. There we go. So just a quick one before I start. Unfortunately, Andrew wasn't able to make it. He just had a family emergency. But hopefully we should be able to pick up any questions that are more on the kind of Puppet specific side, and then we can send them along afterwards. But otherwise, let's get going. So quick introduction. My name is Peter Souter. I'm a technical account manager at HashiCorp. I'm based in the UK, as you can probably tell from my accent. And I've been using the HashiCorp stack and Puppet for about 7 years now. So Puppet started at about version 2.6 maybe back in the day, and I've been using HashiCorp tool ever since Vagrant. I've worn a lot of different hats in my time. So I've been a developer, I've done consulting, done a little bit of pre-sales, and now I'm a TAM. And I'm interested in making people's operational lives easier and more secure, and DevOpsing all the things. And here's Andrew's slide, but unfortunately he's not able to make it. So let's talk about the landscape and some background to what we're going to talk about today. So assuming that most people on this call, maybe not everyone, is using Puppet to manage systems. So you've kind of got to this point, you're very happy, your infrastructure as code has been great, and everything is awesome. You're managing all your systems with Puppet. But then you have that kind of sinking feeling when one of your sysadmins or engineers or SREs, whatever you want to call them, comes up to you and says, you know, oh, this Puppet stuff's great, but I accidentally left one of the production passwords in plain text in the Puppet code. And then, unfortunately, instead of pushing it to the private Git repo, I accidentally pushed it to the public Git repo. So we should probably do something about that. So managing secrets is hard. It's not a unique problem to Puppet, but obviously due to the nature of the systems that you're managing with Puppet and what applications you're managing, you're more likely to have those kind of secrets pop up. And Puppet code just needs to be treated like any other code. And you need to make sure at least that your secrets are encrypted at rest. So when you're writing Puppet code and thinking about the security aspects, you need to think about some things. So how do you rotate your secrets? When they are leaked, how do you know if they're leaked? When a new team member comes on board the team, how do you actually onboard them and how do you introduce them to how the secret process works? How do you give them the passwords in the first place? When you need a new secret, how do you actually get that introduced into the code? And how do you track when secrets have been changed? So if someone says, oh, we have had a leak, or oh, we have to change this password, it's within the 30-day sort of rotation window, how do you actually know that that's happened? So we're not going to talk too much about the specifics with Puppet. I actually did a previous talk about this at PuppetConf 2016, where I kind of talk about some of the best practices with secrets in general, less about the kind of specifics around encryption, more about the kind of best practices and tools you can do with Puppet. So that link will be in the slides at the end, but I would check that out if you want that kind of information. So there are some existing secret management solutions that are out there already. So I'm assuming that most people are probably using Hiera YAML right now, which is the ability to encrypt secrets into a YAML file using a asymmetrical encryption, so with a private and public key. And there's a bunch of other solutions that are not Puppet specific, but other people will start using them. So Blackbox was a similar solution that was actually created by the team over at Stack Exchange for their Puppet infrastructure. You have tools like Mozilla's SOPs, which is a similar tool. It's basically similar to what GitCrypt is doing. So it's just standard public-private key encryption, but with some cool helpers to make it a little bit better. All of these solutions have similar problems. The rotation process is a little bit fiddly. I don't know about you, but I'm always having to look up the man pages for things like GPG, and there's always something that I forget. Onboarding the new team members is a little bit harder because get that kind of initial introduction process of getting the keys into the other team members' hands is a bit of a pain. It's a little bit harder to keep track of who changed what, and there's no real easy way of auditing what secrets are being used where. So if only there was some sort of secret management application that we could tap into. So luckily, we have that. We have Vault. So one of the cool things about Puppet itself is that we can actually use Puppet to configure Vault. So I use the JSOC Puppet Vault module for this demo. For this example, it's pretty much as you expect from any sort of Puppet code. We're basically having a Vault class. We're configuring what entries in the config file we want to run. For this example, we're running it in a very insecure mode. We're only running it with the file storage. We're not using the console backend. We're running it without SSL certs. We're disabling TSL. We're setting TLS disable to 1. And we're going to enable the UI as well. So Hiera itself is just the, if you're not familiar with it, is the data backend to Puppet. It's the main way that Puppet gets information from another backend. So generally that's going to be a file on disk, be it a YAML file or a JSON file. But you can basically plug it into anything, even databases like MySQL. So in this case, all we need to do to plug Hiera into Vault is a little bit of Ruby glue. So recently, the way that Hiera works was changed a little. So you can actually have per branch and per Git branch Hiera setups. And this is what part of the kind of Hiera 5 lookup change. So luckily, Dave Alden has created a new Hiera Vault backend that's specific to Hiera 5, and actually has a lot of benefits that we're talking about in a second. So how does the actual config for the Hiera backend look? So we have this hierarchy, and inside here are some options that will help us kind of configure how Vault works. So in this example, we're connecting to Vault on the hostname Vault, port 8200. We're giving it a token. We're saying that the Vault field that we're going to look up is value, because any the key value that can look up a JSON, where we're just going to assume that the value we look up is value. And we have what's known as generic mounts. So this is similar to the kind of hierarchy you'd have in a standard Hiera lookup. We're saying that we're going to be looking up the secrets in the secret backend under Puppet, and the key that's going to be looked at is the trusted cert name of the system. So if you're not familiar with trusted cert name, these are basically facts that are stamped onto the agent on first check-in, and they can't be changed. So this kind of helps us without, you can't spoof a host name of a system and then fetch the kind of production credentials there, as long as the certificate signing process is being done properly. There's some other keys in here that I'll kind of talk about and highlight. So one that comes up, and this is one thing that I've kind of talked with people about previously with Hiera and Vault, is the idea of a confined to keys. So by default, Hiera will look up every single parameter of every class that's in your code. So the problem with this is that this could be, hundreds, maybe even thousands of parameters in your code. And then if your system is constantly having to talk to Vault to look for this information, not only are you increasing the compile time, because it has to do a fetch every single time, you're probably also filling your Vault logs with a bunch of false negatives. So if you looked in your Vault logs at the time, it might be looking up a parameter for every single class you've got, which is going to be, not very good. So what we've got is a key called confined to key. And this is basically a regex that will limit when the Vault backend will actually look up a key. So in this example, the one I've given here, we're only going to be doing a Vault lookup if the lookup key specifically contains Vault, specifically contains the word password, either at the end of the string or with password ... Obviously, you could change this and you can make it so it looks up for everything if you really wanted to. What we also want to do is create a specific Vault policy for Hiera. So Vault policies are basically kind of ACLs for Vault. You could use the root token for your Hiera lookups, but then the problem is if that root token gets leaked, or if something happens in the Puppet code, you could basically, look at loads of secrets that you'd not been given access to. You could delete secrets, things like that. And what Hiera's role is just to read secrets. So we're going to make it so it can only look up the path secret Puppet asterisk, so anything under that path. And all it can do is read and list. So architecturally, it looks like this. We have a Puppet master. When a catalog is being compiled, it talks to Hiera. Hiera checks the Hiera backends, and it goes and talks to Vault. Then the catalog is sent down to the Puppet agent containing the secrets in there. So one of the cool features, we mentioned Hiera 5 having a bunch of cool new features, has a new ability called the explain feature. So this is very useful for basically doing a lookup of your system. So if you basically need to check if you're debugging why a particular Vault lookup isn't working, this can be very helpful. So in this example, we're looking up Vault lookup example. You can see it's configured to go to Vault. It's looked at that path and it's found it. So it's told you what the value is there. So for example, if you can't find it, maybe the connection to Vault isn't working, or maybe the key has been misspelled or something like that. So this is very helpful for debugging. So with that background, let's get to the demo. So as always, with any kind of demo, hopefully this all works fine. I've tested it a million times, but you never really know. So we'll be praying to the demo helpers for this. And this is a very sandbox example. It's not hard into production standards. So it's things like the Vault cluster is running on the same machine as the Puppet master. It's using the storage backend instead of console. You know, this is just an example of the sandbox. But that said, let's see if we can get this working. So just going to switch to my main screen, exit out of this. And let's make this a little bit bigger. So what we have here are 2 nodes. So let's make sure they're still up. Fantastic. I did this a few times and they'd turn themselves off when I was doing the demo, so a good thing that didn't happen. So we have 2 nodes, a Puppet server node and a node 1. So the Puppet server node is the thing that's connecting to Vault itself, and the node has no connection to Vault. It's receiving catalogs from the Puppet server that are connecting to Vault. So right now, if I switch to my Puppet code, the token I'm using is the master token, which is a bit OTT, because that means that if this gets leaked, this is basically full access to anything that Vault can do. So what we're going to do first is quickly create a policy that only allows the lookup of the /puppet things like we discussed before. So if I look in my Terraform folder, let me just quickly check I've got the environment settings set. Yeah, so I've already set these in my environment. So this is my root token, and this is me pointing to the local Vault instance. So if I do a Terraform plan, you can see it's going to create a new secret under the node 1. It's going to create 2 new policies, a Hiera Vault and a Hiera Vault operator. So the Hiera Vault only has read and list. In fact, I'll look at the Terraform code to make it a little bit easier to read. So the Hiera Vault operator, we're going to be using this to look in the GUI, and this basically has the ability to change any secret. And then we have the regular Vault policy, which is the policy we're going to use to create a token for the actual Vault lookup itself. So let's do a Terraform apply. Say yes. Cool, so we've now created all those policies there. So we're now going to say Vault create token dash policy equals Hiera. Oh, what have I done? Sorry, Vault token create. I always get those mixed up. Here we go. So I've now got a token that will only use the Hiera backend. So if I go into my Puppet code and I change this token here, this will only be able to look up that particular thing. But we also want to be able to log into the GUI and kind of look at things there as well. So let's do a Hiera operator as well. So this one, it's still restricted to the Puppet backend, but it will allow you to create and delete tokens, and we can actually look at that. So let's double check this. Let's find out. So I'm using the token we just created. So this one here, I'm going to log into the GUI. And if I look, there is under the secret key value backend, there's Puppet, there's node 1, Vault notify with value hello world. So let's log into the node 1. So to show what's actually happening here, I will show my Vault message profile. So of the 2 nodes, the Puppet master node has a profile that will actually set Vault up, and it'll actually configure the Vault backend, so installing the Vault gem into Puppet server, things like that. But for my node, I've just got a very simple bit of code. We're making a variable from a lookup. We're looking up Vault notify. And then we're seeing, if it can't find it, it will say no vault secret found. So when we do this testing vault notify, if we go back to this, we should see hello world. So let's see if that works. So remember, this agent node has no connection to Vault whatsoever. It's all being done through the master. Then the catalog is being sent down to the agent with those secrets in it. There we go. So testing Vault, hello world. So then if I quickly go into here, I edit this value and say hello world changed in GUI. I save that here. I run that again. You can see it saw that change immediately happen. So that's all cool. So we can also test if that value doesn't exist, what actually happens. So let's just edit this and delete the key. Oh, sorry, not that one. You have to delete it itself. So click that, click delete secret, click delete. So that won't be there anymore. If I run this again, because in this particular lookup, I'm saying default value, no vault secret found, it won't throw a catalog compilation error. So in terms of good practice, generally you actually want to error out if there's no value found. But in this example, we want to show that it's not finding that value there. So then if I go in here, I delete this default value bit, I do another run. There we go. You can see it's actually giving a catalog compilation fail because this is what Hiera does by default. If it can't find a particular value, it's going to throw an error. And that's pretty much the kind of full gamut of how that works. So what are the advantages and disadvantages to this approach? So like with any tool, there are many different ways you can actually configure Vault to work with a Puppet environment. This is probably the most drop-in and kind of like Puppety way of doing things, because the way that Puppet expects kind of data to come in is through the Hiera layer. So in terms of that, it's the easiest solution because it works the most in the kind of Puppet ecosystem. You're minimizing the connectivity requirements because the only connection you need to Vault will be from the Puppet master. And because it's using Hiera, you can use the kind of standard debugging tools like we talked about explain earlier on. The problem with this is that you can't do the kind of finer grained control you get with something like a cubbyhole system. There is kind of like, it's the classic advantage disadvantages kind of way, where because all the connections are going from the Puppet master to the Puppet agent, as long as your certificate signing process is being done correctly, because we're using the trusted cert name attribute for the key value lookup, as long as the system has the right host name that it's supposed to, it should work fine. You know, if your certificate signing process is incorrect and someone creates a new node called like prod.db and it can get that information, then yeah, that person will be able to extract secrets. But in that example, the kind of like the key bit that you need to make sure is correct is the certificate signing process. So this is the kind of key way you can do it for Hiera backend, but there are alternatives. So one pretty common alternative, and this is not specific to Puppet, but you know it's one of the examples we give, is you can actually use Puppet. You can use consul-env or template. So in this example, basically, you're basically pulling the responsibility away from Puppet itself and into consul-env/template. So consul-env is probably better more for a kind of container infrastructure, with consul template probably better for something that's an actual application on disk. So what it does is basically you have a template file like this. You have a little bit of Golang templating. It will say with Vault, you give it the backend you want to talk to, and then with that data, it will actually be able to configure a template like that way. So they're actually, I've been testing this out myself. I didn't have time to add into the demo, but there are a bunch of really good console template examples on the Forge, the Puppet Forge, which is the kind of module repository Puppet code. So you can actually use Puppet to configure console template that way. And then in that case, it's being configured that way. So the advantage here is that, as soon as a change is made in Vault, this is being changed directly with console template. But then the disadvantage is you're pulling it away from Puppet, and this is not good for everything. So for example, you wouldn't be able to do it with non-templated resources. So let's say you're managing users on the system, or you're performing an API call, or you're running an exec or shell script. You wouldn't be able to use it in a template, maybe. You'd have to actually go fetch it from that way. So it's just one approach. The other big approach is direct integration. So in this case, you're kind of pushing up the stack. So instead of doing it on the kind of operator level, you're doing it on the application level. So in this example on the right, this is actually from Vault Rails, which is maintained by HashiCorp ourselves, because we use it for some of our internal projects. So what this will do is that this is quite clever because it actually talks to Active Record itself and is fully using the ORM model. So you just pick a particular attribute. You basically say that attribute is now a Vault encrypted attribute. Then when I create a new model, so let's say a new person, we're adding a social security number. When you say save, there will be an encrypted value called SSN encrypted. So in terms of like the best way of integrating with Vault, this is the closest you can get to the metal with Vault. It's much more performant. You have lots less responsibility. You're pushing the responsibility onto the kind of dev systems. The problem with that is obviously it's a much more engineering effort. It requires that the application itself has to be aware of Vault in the first place, whereas the approaches with the Hiera backend or the console template system, the application has no awareness of what Vault is. It's just reading an application, a template file on disk. So it might be a little bit slower to integrate. So if you've got an existing estate, it might be a little bit harder. But it's the kind of best way of doing things. And obviously with this, you can actually configure this with Puppet itself. So maybe you have a rails.yaml file. You can configure the actual base configuration with this. And the two I know do the best with this are probably going to be Vault Rails and Vault Spring, which are directly integrated. Cool. So I've gone way faster in this than in my trial dose. So we've got a lot of time for question and answers, and I can see a few coming in. So I'll pass it over to Amanda to see if we've got some questions coming in and see if we can give those some answers.
Great, thanks, Peter. So we do have a few questions coming in, and everyone in the audience, just as a reminder, feel free to submit your questions and we will get them answered for you. So Peter, the first question, someone's wondering, how do you protect data from handmade manifests from unprivileged users?
I see. So the question is, so if someone can just write a manifest that does a lookup into Vault and pulls the information out, I guess is the question there. And I think that's the kind of question. If not, then feel free to do a follow-up and I'll follow up on that. But this is a kind of common problem with the kind of the workflows of any kind of big config management tool. There's a few solutions to that. One is the standard, the caveat of there should be processes for code being brought in. You should have some sort of pull request workflow. So if someone's writing a new manifest and they're going fetch production DB passwords and pulling stuff down, then that should be highlighted. But one of the defensive options you have is that the backend config from the Hiera file. So the only way someone would be able to extract secrets would be to actually run that secret fetch on the system that's been restricted to. So let's say you've got a production Postgres database, you need to configure some passwords in there. The only way you'd be able to get those password credentials would be to run a Puppet run on that actual system that matches the host name that's imprinted on disk. And then obviously if someone has SSH access to that and root, then it doesn't really matter if they can get the secret because they can just look at it on disk. So that's the main defensive way. So the other part of it is that there is a new sensitive field that's available in Puppet 4.10, I think it was. Let me pull up. Let me exit out of this. Puppet sensitive. So what you can do, depending on how you've restricted kind of access to the kind of reports that are coming in from Puppet, you can mark a variable or even a template as sensitive. And then when it comes up in reports, it will be basically hidden. So then, in fact, you can even see this example here. So if I say notice secret, you'll see sensitive value redacted. So if someone tries to write a clever manifest that fetches information it's not supposed to get, the only way they'd have access to that information in the reports is like being on the system itself, because it'll be hidden from the reports. So that's one way of hiding that as well. Hopefully that answers your question. If not, I can follow up.
Awesome. Thank you, Peter. Okay, the next question. Someone's wondering if the solution can also work on a Windows server.
Yeah, no, it would all work the same regardless of what OS you're using, really, because all that's happening is when the catalog is sent to the system, it doesn't matter if it's Mac or OS X, it could be AIX, it could be Windows, it could be any flavor you want. As long as the catalog is being sent to the agent and the secrets are in there, you could use it to configure IIS, you could use it to configure, PowerShell scripts. It would all work the same way regardless of what operating system you're using.
Great. Okay, thank you for the clarification. And then the next question, Peter, someone's wondering if there's a way to avoid putting a vault token in plain text in Hiera. So they said maybe YAML. They're kind of wondering for clarification.
Yeah, it's a bit of a chicken and egg problem, right? Because at some point you need to give the token to the configuration. So in this case, if someone has root access to your system so they can look at the Hiera config, then at that point they'd be able to edit the Hiera config to whatever you wanted. You could configure it to look to your compromised files or something like that. But there is one, I believe the Hiera backend that we're talking about actually has one solution to that, which is to hide it as an environment variable. Let me just double check. Yes, so you can actually run this, you can run it from the environment as Vault token. So what you could do, depending on what system you're using, if you're using system D for the Puppet process, so for the Puppet server process, you could add to the environment Vault token equals and then give it the token you want. That means that you'd still have the same problem, which is it would be hidden in the process window or in the environment, but at least it wouldn't be in plain text in the config itself. So if someone had access to the Git repo, they wouldn't be able to go fetch that token. But the idea would be that that token would be restricted to a policy that only can read secrets. So it wouldn't be a huge disaster if that got leaked, but yeah, as you say, it's still something you want to keep in mind. So keeping it in the environment is probably a good way of doing it that way.
Okay, great, thank you. Okay, and then someone's wondering if you have any metrics or info on performance impact for Hiera-based approach, especially where you have many classes with many params.
I don't have any kind of solid numbers, but when I was playing around with this, if you use the confined to keys well, it's pretty negligible because one lookup is like pretty fast. Obviously, if you didn't have this confined to keys, this could be hundreds and hundreds of lookups. It would be a lot slower. So it basically depends on how much you want to push into Vault itself. Like, do you even want to put parameters into Vault that aren't really that sensitive? It might be a bit over the top. But in terms of performance, I've not seen a huge impact. I think the confined to keys is really good. And there was actually some pretty good blog posts by other people who were trying to solve this problem because they were having a similar thing where every time it's fetching to a different system, that's obviously added compile time. But I found with confined to keys, if you've got maybe you have some core things that have to be pulled from Vault, and that's only 5 or 6, that should be a pretty negligible performance impact. But if anyone has any kind of real world experience and wants to kind of give me some numbers, anonymized obviously, if it's sensitive stuff, feel free to reach out.
Okay, awesome. Thanks, Peter. That's helpful. So then someone's wondering, related to that, is it, just to follow up, they're saying, is it potentially a big security risk to have the token in clear text in Hiera? What are ways to
Yeah, I mean, it's the same as, at some point you need a token to talk to Vault, right? And you can try and make that a little bit more secure, as we said, by having more restricted policies. You can try and make that a little bit more secure by using an environment variable. But and this is one of the things I should have actually mentioned when I talked about some of the problems here. What would be nicer, and obviously someone would have to do a little bit of work for this, is to have some sort of automatic secure introduction. So instead of having to rely on the token, it would use some sort of authentication on the kind of the cloud level. So maybe it talks to Amazon KMS to verify the system is correct. And in that case, you're kind of pushing the responsibility from the kind of token app role from the Hiera system onto that kind of introduction. You'll basically talk to AWS and say, is this system real? If so, then allow that token to be done. But you're kind of pulling the responsibility away from Puppet into Vault in that case. So there is probably a way of actually, I haven't looked too deeply into this, but maybe you could even use the CA of Puppet, the Puppet CA itself to authenticate the systems and do the authentication that way, but I haven't done a huge amount of work on it. If anyone has any ideas or anything, or has done this themselves, then feel free to reach out, because that'd be really good to know, and I can do a follow-up and kind of talk about some of the alternatives that are more puppety of doing this.
Awesome. Okay, and then someone's asking, Peter, is there any support for other kinds of Vault secret backends other than generic key value? In particular, they're interested in the PKI backend.
Right now, this is pretty simple because this is using Hiera itself. It's just using the key value backend, but I don't think it would be too hard. So you can actually write functions in Puppet code, right? So you could write a new function that would actually go and try and use the PKI backend. You would have to do a little bit of work yourself, but you could write a function that would, for example, talk to the PKI backend, do the loop, and get the private key, and then maybe like some sort of function called like vault underscore PKI, and it would return a string, which is the private key, and then you could create a new file on disk that had the contents of that. But someone would actually have to do the work. That'd be less of a Hiera backend. That would be almost like new functions that are being made to talk to Hiera. Sorry, talk to Vault. Definitely possible, but I haven't kind of investigated too deeply yet. And the same for any other backend, like if you're using the database credentials backend, or maybe the cubbyhole backend that I briefly mentioned in the talk. So it's possible, but I haven't played around with it too much myself.
Awesome. Okay, makes sense. So next question, and thank you. There's lots of questions now rolling in, Peter, so I hope you're ready. Which plugin do you recommend to use for Ansible Vault integration? Someone's saying Puppet's great, but they also think Ansible is interesting.
I haven't played around with Ansible too much, but I assume there is a similar kind of backend. From my experience of Ansible, it has, I can't remember the name of it. I think it's even called Ansible Vault. I did, but not HashiCorp Vault, but Ansible Vault. And I think that has some way of talking to Vault directly, but I haven't had too much experience with it. It definitely probably exists out there, but I haven't played with it too much.
Okay, great. And then can you talk about secret audit and version control on Change?
Yeah, sure. So is that like the idea of auditing what change has been done? So let me log into Vault itself. Yeah. Grab Vault. So in this case, I'm using the root token. But if I go to access here, and then I go to token here. Oh, no, sorry, it's leases, isn't it? Token, create. So from, and this is mainly through the GUI because it's a lot easier to kind of demonstrate, you can kind of audit what backends are being used, when tokens were created, who created them, how often they've been used, when they run out, and things like that. So for example, if you wanted a kind of a much more kind of paranoid but secure way of doing the token, you could even make it so that the Hiera backend token is either manually or automatically rotated every 30 days, or maybe even every 7 days. So that means that even if you leak the token in Git code, or if someone accidentally looked at, saw it in the environmental process window, you'd be able to basically rotate it immediately, and people wouldn't be able to have access to those secrets there. So this is all part of standard Vault. This isn't a Puppet specific thing, but you have the ability to audit like what's hitting what backends and what tokens have been given out and when they've been given out and things like that. So that's all part of the kind of standard Vault, and I'd say go and look at the docs around the kind of policies and the auditing that's going on there as well.
Cool. Okay. And then a few people have asked, Peter, they're wondering if there are any advantages to using Hiera. I don't know if I have that pronunciation right, to talk to Vault as well as.
Oh, yes. Yeah, so Hiera is something that I've played with in the past. And I don't know if, I can't remember how you spell it. Hiera. Puppet. This is when, yeah. It's actually, maybe it's doing it in my history. Yeah, there we go. So Craig Dunn, who you might be familiar with, he's written a lot of really cool stuff out there. He wrote the Hiera HTTP backend, which is pretty good for plugging into any kind of system. He basically wrote a kind of, it's kind of like a meta layer on top of Hiera itself, or Jerichiah. I never actually asked Craig how you pronounce it. So the idea is that it's a kind of indirector that you can put in front of Hiera itself. And then from there, he was using it with some customers to, or even, I don't know about customers, but he was using it with some places that he was consulting at, and that would talk to Vault directly. So that allows you to do a lot more kind of indirection there. So I'd recommend going to read Craig's blog. I haven't had the chance to play with myself, but Craig's a really smart guy, and he's done a bunch of really cool Puppet stuff. So I'm pretty sure that it's a good system. I just haven't used it myself. And I can add that to the links that we send out when we send out the slides and follow-up questions and things like that as well.
Awesome. Okay. Next question. Someone's wondering, is it possible to lock down the token used in Hiera so only the Puppet master can use it?
Do you mean from a, it can only be used from a certain IP? So from my understanding of the policies, you'd only be able to use that with a Vault Enterprise feature called Sentinel. So from there, you'd be able to access things like which connections Vault can be made. On a more kind of like over-the-top approach, you can make it so the only system that had direct access to Vault itself would be like a firewall rule or some sort of binding rule. So only the Puppet master could talk to Vault. But if you're talking more on a policy kind of method, you could use Sentinel to restrict only the Puppet host name or IP to talk to that particular backend. So you could do it that way. So either from a kind of system level perspective, which is a little bit more blunt, or you could do it from a policy level perspective with Sentinel, which is a Vault Enterprise only feature.
Awesome. Okay. And then next question, Peter, someone's asking, what's the granularity of the secret recipient at runtime? A host, an app process, VM, container, whichever possesses the client auth token. Wondering.
So in this example, the scope of the secret is basically whatever you set as the kind of mount. So in this case, it can look up any secrets that are pulled under secret Puppet, the name of the system. So generally, that's going to be a parameter lookup. So if someone, if it's going to be like a Postgres database, if it's going to be a particular parameter or something like that, but you could set it to whatever you wanted. It could be the OS of the system. It could be what data center you're in. Any kind of information that Puppet can call from factor will give you the scope of where that kind of secret is. And as long as the secret is under secret Puppet or whatever you've chosen as your kind of policy to restrict access to that secret, it'll be restricted that way. And the agent itself has no awareness of Vault. So the agent isn't saying like, I am connecting to Vault to get the secret. The agent just gets given a catalog with the secret already in it. So all that logic is being done on the Puppet server level, not the agent level. So it has no awareness of Vault really.
Okay, great. And then this is a great question, Peter. Someone's saying they're newer to HashiCorp, and so they're wondering about Consul and why we recommend it for production deployments.
Console as in, oh, it's the backend for Vault? Oh, yes, I see what you mean. So yeah, there are multiple backends to Vault, so Vault backends. And the reason we recommend Console is that it's the most highly available and it's the most scalable, basically. So there are a bunch of backends that you can connect to. So you can use S3, you can use in memory, for example, if you're doing a quick test. So the dev version of Vault does everything in memory. For this demo, we're actually using, file system storage. So this is being done literally under a mount on the system. Console is basically the recommended because Console is highly available, it's HashiCorp supported, it's the model we use for kind of distributed systems. Console is self-healing, it can like do leadership election. So if one of the console listeners goes down and then it can recover and kind of pull up, it's a lot easier to horizontally scale. There's a bunch of really good benefits to that. A lot of the other backends aren't actually HashiCorp maintained. So obviously we'll help out if we can, but generally those are being maintained by the writers themselves. Whereas the console backend is one we actually use for not only, we recommend for the community, but that's what we use for our enterprise deployments as well. So it's officially supported. It has a bunch of really cool stuff, and console itself is really cool, and there's some really cool stuff coming into console as well. So I can give some more follow-up documents on the kind of whys, but that's the kind of general summary of why we use console as a backend.
Awesome. Thank you for the clarification. So now kind of going back to the demo, and there was that Windows question earlier, Peter. So it might be the same person, I didn't catch it, but they're asking if Windows is fully supported, like in Linux.
From a Vault perspective, I can't remember. I don't think there's any real blockers to running Vault on a Windows system. I wouldn't obviously don't take my word for it, but in this case, Puppet is fully supported on Windows or most modern Windows systems. I think it's still 2008 R2, 2012 R2, and 2016. So, and as I said, the Puppet agent has no awareness of Windows. Sorry, it has no awareness of Vault. So it's not really a question of is it supported on Windows. The agent itself is supported on Windows, and that's talking to the Puppet master. The Puppet master itself isn't supported on Windows. There's actually been a little bit of work on that, but right now it's Linux only. So even if you have an entirely Windows estate, you need at least one Linux system to run the Puppet server on. So in terms of that, the only bit that really requires the only bit that would be a blocker on Windows is you need a Linux system for your Puppet server, Puppet master kind of infrastructure. And I think Vault runs on Windows. I just don't think we recommend it. It's a Go application, so as long as the Go libraries work on Windows, it should be fine. But I can do a follow-up on that and talk to our team and see if there's any kind of blockers around Vault on Windows. I'm not sure.
Okay, and then moving over to AWS, someone's running on AWS and they're wondering if they can use the AWS auth on the Puppet server so that they wouldn't have to put the token in YAML or as an environment variable.
Yeah, the way that the backend is set up right now, it assumes you're going to create a kind of app role token. But that's one of the things I talked about when I talked about it'd be nicer if it had some way of using Amazon's IAM kind of backend to do all the work automatically. There already exists a Hiera KMS, which basically does it that way. So in that case, you're talking directly to KMS and doing it that way. It's possible, but I don't think the backend supports it now. It'll take a little bit of work, but it wouldn't be super hard. You basically have to write the Ruby logic to, instead of using the token, to basically take the certificate of the metadata on your system, fire off to the AWS API, make sure that it matches there, and then pulls it out. And that's actually the workflow for the IAM workflow for Vault generally for secure introduction. So you just need to basically plug it into Hiera and do it that way. So it's possible, but I haven't had go of it yet.
Okay, great. And then next question. So someone's saying, so Vault protects me from unintended use of hard-coded passwords from my code. And do I need to use Terraform?
So one of the things on our docs is to say that, I guess there's two parts of the question there. Do you have to use Terraform to set up Vault, I guess is the question. No, you could do it all from the command line, or even if you wanted to write your own Puppet provider that way. If the question is the kind of like Terraform versus Puppet, I think they serve very different uses. Even in our own Terraform documentation at HashiCorp, we say that Terraform is not a config management language. Does that mean that people sometimes use it as a config management language? That's true. But Terraform is more kind of interacting with APIs and systems. We generally say not to use it to configure like the actual kind of packages and things like that on the system. Like, there are things like the provisioners, which use SSH and WinRM to talk to the systems. But generally, I'd say that's probably better left to a dedicated config management tool like Puppet. But people have different opinions on that kind of stuff.
Okay, great. And then this is a good question, Peter. So jumping back to console, someone's wondering, this is always a question of the chicken and egg issue, how you keep console secrets when Vault depends on it. And they're asking for any shareable experience on the combination of Puppet, console, and Vault.
So in terms of console, the secrets that are kept in console are encrypted inside console, and then Vault decrypts them. That's how the backend works. So even if someone had you'd lock down console as you would with any other system you've got. But even if someone had access to console, they'd be looking at ciphertext. So they're encrypted in console itself and decrypted by Vault. So you don't really have to worry about that side. In terms of how that all works with Puppet, again, Puppet talks to Vault, Vault talks to console. Puppet doesn't talk directly to console. And the secrets are kept encrypted inside console. So you don't really have to worry too much about that part.
Awesome. Okay. And so now someone's wondering if they have a suite of applications, instead of integrating Vault directly into every app, can they create a single microservice which only does the secret management and interacts with Vault for any service on their cloud?
Oh yeah, definitely. Like one of the things we try and do with Vault, there's even the idea of we have pluggable backends. Right now, they have to be compiled into the Vault binary, which isn't super convenient, but we're looking to extend that in the future so they're more pluggable, similar to using Terraform providers. But the idea would be that you're not really restricted to what systems you use in Vault to kind of authenticate and get these things down. It will plug into pretty much anything you can think of there. So right now it's not as easy as it could be. We would definitely looking to make that a bit easier in the future.
Awesome. And then, so next question, we'll get through as many as we can. So someone's saying, it seems like David Aldian's Hiera Vault Puppet module restricts us to only looking up a secret with the key of value. Is there a way to look up other key value data in the same secret without having to change the default field option in the Hiera YAML?
I think, let's have a look. I think when I looked at the code, there is a little bit of logic to actually to pull out the entire JSON field, I think. I'd have to get back to you on that. I definitely remember thinking the same thing. I think there might be a way of specifying what field you want, so it's not always looking at the value. So yeah, if you have more complex secrets that are maybe like different JSON fields and each one needs to look at a different part, I believe there is a way. It might not be in the README docs yet, but it's definitely possible. I'll follow up on that and see if I can open a PR and see if I can fix that bit. But yeah, right now it will always look at the default field value, but I think there is some way of configuring it to do it a little bit more complex and do things like JSON matching and things like that.
Awesome. Okay. And so now we're going to jump to the OSS UI. Peter, someone's saying they have the OSS Vault UI installed, but they're not able to issue a new token. Is that not implemented, or are they doing something wrong?
I don't believe you can create tokens from the UI. Oh no, wait, I think you can actually. Let me double check. I believe you can. I actually haven't had a huge amount of experience with the GUI. This is pretty much all that I've learned as I was doing this demo, but I can definitely talk to the team and get a follow-up on that. I'm pretty sure you can issue new tokens from the GUI because I remember seeing Mitchell do something similar, but I might be wrong. I'll follow up on that.
Okay, thank you. Yeah, we've had quite a few major Vault releases recently, so it might be in there. And then the next question, so they're asking if they save a token on disk in file, when will Puppet server read it? Each time for each host when I'll run Puppet agent T, or it will cache it in memory?
I'm pretty sure, yeah, so in the new version of Hiera 5, in the old days of Hiera 5, if you made a change to the Hiera file, it would only be picked up when you restarted the Puppet server service. From what I understand, I'm pretty sure that now it's actually, you have these like environment-based Hiera backends. It will basically read it as soon as it's changed on disk. I might be wrong there, but I'm pretty sure as soon as this is changed, in fact, like from my demo, I think that is how it works because I actually changed this token. So if I go and pull that token I created earlier on, token, I was in this window. Yeah, so I pull this token from here and I change it. Oh, no, that wasn't there. Let's change it to this token. And I do a Puppet run now. It should still work. So I'm pretty sure, I might have to double check the docs, but I think from a Hiera 5 backend perspective, as soon as the file is changed on disk, Puppet will reread it. But if not, it will be kept in it'll be kept every time a catalog compilation has happened. So it's not kept in memory. It's like every time a catalog compilation happens, it will go talk to the backend, see the token it has to use it, and then after that it won't. But I can follow up on that and make sure it's fine. Oh yeah, the key doesn't exist anymore. So. But I can follow up on that.
Okay, thank you, Peter. Okay, and just 2 more questions. So someone's asking for any recommendations you have on Vault and Git integration, so change is tracked and yet still remain secure.
In terms of, I guess this is making sure that you don't have, I'm not really unsure I understand the question in terms of Git integration. In terms of making sure that you don't have secrets accidentally in your code itself, I do mention that in my previous talk. There's a bunch of really cool tools out there. So I think it's called Truffle GitHub. There's a pretty cool tool called, oh yeah, there's Git All Secrets, similar tool. There's a few out there. I remember Trufflehog is one that I gave in my example. So what this will do is it will basically look through a Git repo and look for strings that look like they're secrets. So in this example, it's gone through your repo. This is some Java code, it looks like, and it's found that someone's made, got a secret, which is AWS secret key with a secret key in there. So it's pretty useful for going through a repo and kind of cleaning up and making sure you don't have any leaked secrets in there. If I'm misunderstanding what you mean by Git integration, feel free to follow up, but I think that's what you mean there. So there's a bunch of tools that are out there to kind of go through your repo and make sure you've not leaked secrets.
Great. Okay, and then are there any security concerns to using the file system backend, or are they just availability concerns?
From my understanding, I don't think there's any security concerns because everything is kept as ciphertext on disk. So the only way you'd be able to decrypt that would be to get the actual encryption key from Vault itself. So it's just like anything else. Like if someone got access to that system and then went into the file directory, they wouldn't be able to look any secrets in there unless they had the key to Vault itself. And the only way they'd be able to do that is if they had a root token and had the ability to get into Vault itself. So if someone managed to get onto your system with Vault, you could seal the Vault and they wouldn't be able to get in anyway. They'd have to find out whatever system you're using to unseal the Vault and do it that way. So I don't think there's, as far as I'm aware, I don't think there's any security concerns around the file mount. It's more about the availability. And obviously it means that if your file system failed or your storage cluster failed, you'd have no real way of getting that back unless you had backups or something.
Awesome. Okay, and then 2 final more logistical questions, Peter. Someone's asking if they can get the slide deck.
Yep.
Which, yes, we will post the slide deck with the recording on our website. So we'll get that out to all of you. I know a few people were wondering. And then the other question, Peter, is someone's asking if you can share your Hiera YAML with everyone.
Yep, right now that the Git repo is set to private, but as soon as this is done, when we send the follow-up stuff, I'll send a link to the Git repo itself. And feel free to, it's all MIT licensed if you want to open a pull request or you have a cool idea to add something in. If you want to do something like add in the console template stuff in there and want to kind of show that and how that works with Puppet, feel free. It's all going to be on the repo and free to use. So.
Great. Okay. Yeah. And I'll also include the GitHub link in the webinar recording page. So,
yeah.
So we'll have all of that available to all of you. Okay, Peter, great job on the questions. That is all of them. So I hope everyone enjoyed today's webinar and is better equipped with using Puppet and Vault for secrets management. Thank you for joining, and a big thank you for Peter for his time today and answering all those questions on the spot. I also want to mention 2 additional Vault webinars we have coming up next week. As many of you know, GDPR goes live this Friday, May 25th. So the first webinar on Wednesday will be with our Vault product manager, Andy, who will give an overview of GDPR and how you can use Vault to help your team achieve compliance. Then on Friday, Lance from our solutions engineering team will expand on Andy's webinar with an in-depth demo of the Vault features we specifically built for GDPR compliance. So I hope you can join us for those. I'll include the links in the follow-up email that goes out today with the recording from today. You can also find the registration links for those upcoming webinars on our website at hashicorp.com/events. And finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I will send an email out to all of you and everyone who registered with the recording link. You can also keep your eyes out on Twitter. I'll post the recording link there a little later today. So with that, thank you everyone, and have a great day. Goodbye.
Thanks everyone. Bye.